Hi everyone, this is your math guru. In this video, I'm going to show you how to find the angle formed between the two lines as shown in the sketch. We have calculated the angle theta, which is formed by the two lines in the diagram below. Round off your answers to do decimal places. In order to find the angle form as shown, which is theta, I need to find the two angles that make up theta, that is reading from my x-axis, and that is the angle formed by BC and the angle formed by the line AC, as shown. These two angles, if I add them together, will give you the value of theta. So I'm going to call the first one alpha, and I will call the second one beta. So basically, my theta will be equal to alpha plus beta. To start, I will find the coordinate of each of the points shown, starting with the coordinate of A. And because A is lying on the y-axis, the coordinate will be the value of x on the y-axis is 0, but the coordinate of y, or the value of y, is -6. If I go to B, the point B is also lying on the y-axis, so the value of x at that point is 0, but the value of the y will be +2. And the coordinate for C, note that C is lying on the x-axis, and on the x-axis the value of y is 0, but we've been given the point x, which is +5. So now that I have my values, I will start with finding the gradient of the line AC. Note that when you're finding the angle of inclination, you read from your x-axis. So I'm going to extend the line AC as shown, and likewise I'm going to extend the line BC as shown, such that if I start with the gradient of the line AC, that's MAC equals the change in y, y2 minus y1, minus the change in x, x2 minus x1, which is equal to, using my A and C, I have 0 minus -6, I'm going to put that in a bracket, divided by x2, that is 5, minus 0. Note that the point I'm using are my point A, which is 0 and -6, and my point C, which is 5 and 0. And tagging my point, I have this as x1, y1, x2, y2. So I've been able to substitute accordingly, and that will give me MAC equals 0 plus 6 over 5, which is a positive gradient, 6 over 5. Note that, like I mentioned earlier, when you're reading your line or angle of inclination, you read from your x-axis. So the value I'm going to get will be from my x-axis in this way, and note that these are vertically opposite angles with my B, such that this angle is also equal to beta. So therefore, to find the angle of inclination, I have tan of my beta equals to the gradient, which is MAC. In this case, that's 6 over 5. And therefore, to find my beta, I'm going to move my tan to the right-hand side. So that will be arctan of 6 over 5. Therefore, my beta equals, you press the second function button of your tan on your calculator, and that's going to be 50,19 degrees. So therefore, putting that in my diagram, I have that as 50,19. The second step is to find my alpha. So note that when you're reading the angle formed by the line BC, that's reading from my x-axis, that's going to be the angle, the obtuse angle formed as shown. But to find alpha, I need the angle formed in this direction, that's my alpha, such that if I can find my reference angle will also be equal to my alpha because I don't need to find my obtuse angle. So therefore, using that concept, the first step, finding the gradient of the line BC. So I have MBC equals to my change in y divided by my change in x. Using the point or the coordinates B is 0, 2, and C is 5 and 0. And tagging my point, I have that as x1, y1, x2, y2. So I'm going to substitute those values. I have 0 minus y1, which is 2, divided by x2, 5, minus x1, which is 0. I'm going to have negative 2 over 5. That's a negative gradient. So note that my angle of inclination, that's alpha in this case, I have my tan alpha equals to negative 2 over 5, which is equal to the gradient of MBC, equals negative 2 over 5. Therefore, alpha equals, or I call that my reference angle, equals the arctan of 2 over 5. I'm going to ignore my negative sign. Therefore, my alpha, which is also my reference angle in this case, will be 21.8. Note that if I was to calculate the angle of inclination of MBC, that's the obtuse angle, then I need to say angles on a straight line add up to 180. So that will be 180 minus 21.8. That's the reference angle. But in this case, I need that reference angle, which would be the negative minus 21.8 degrees. I'm going to put my degrees. So therefore, if I'm to be reading in the clockwise direction, that will be equal to 21.8 degrees. I don't need the obtuse angle. And note that vertically opposite angles are equal, so therefore my alpha is also equal to 21.8 degrees. Therefore, to find my theta, which I stated earlier as the sum of my alpha plus beta, that's equal to 21.8 degrees plus 50.19 degrees. Please don't forget to click on the like and subscribe button below for more easy to understand math concept. Therefore, the value of theta equals 71.99 degrees. Note that we are asked to leave or round off our answers to 2 decimal places, and that's what we have. Thanks for watching. Bye.